Thank you so much for that introduction. Sorry to start with a correction. I'm not just a signatory of the Agile Manifesto. I am the first signatory, alphabetically. So, what a pleasure it's been to be here so far. I'll be delighted to have this talk over, but I've been having great conversations with people, learning lots from different people's perspectives, and it's great to be among a group of geeks. I tend to talk to more business people these days, and it feels great to be home, where I'll be talking a little bit about some math, and I don't need to worry about scaring anybody, and so it's good to be here. In the Bible, it talks about the lifespan of a person being 70 years and 10, 70 years. But with medical advances, of course, we've extended the lifespan. And so I like to think of it in terms of 3 billion seconds. 3 billion seconds is about 92 years. So 2/3 of mine are gone. For most of you, 1/3 of yours is gone. But there's something that's driven me my whole career, which is I hate wasting time. Each second is a precious opportunity, and giving it up to activities that create no value, that aren't enjoyable, is an opportunity never to be returned. Every second, one of these seconds is ticking off. I hope I'm not triggering any existential crises, but if so, feel free to take a moment. And early on in my career, I saw software development activities advocated that were very clearly wastes of time. When I tell the kids these days about documentation measured in meters, they don't believe me. But there really were meters of documentation on a shelf that were then never looked at again. So that's a waste of those seconds. It's a waste of opportunity. What could we do that would be different? Now, we're engineers. When you optimize, you don't maximize. There's always some trade-off. So we can't try to waste 0 seconds, but we sure can try and waste fewer of them. And that was the motivation behind extreme programming. What if we stripped software development back to its essence? And we did the stuff that we absolutely knew absolutely mattered, and we did as little of the other stuff as possible. What's that going to look like? And it turns out it has profound technical, social, business implications if you start from that perspective. But that's the direction I've tried to go with everything that I've done with software development. It's not like, okay, and you can also draw these kind of diagrams, and you can also have that kind of meeting. Sure, there's lots of reasons to add stuff, but what if we stripped it down to its essence and had geeky people talking to people with needs? That's the essence of software development. As part of that process, I've gotten to meet many interesting people, and in 2005, I got to meet 2 of my heroes. I was on a panel at Uppsala celebrating the 25th anniversary of the publication of the book Structured Design. Structured Design is kind of a green book. I had it as a college textbook, and I got to meet the authors, Larry Constantine and Ed Jordan of blessed memory. And as I was preparing for this panel, I thought, I really should read this book. It was a college text, so of course I didn't read it then, and even if I had, I wouldn't have understood it. So I started looking at this then 25-year-old book, 44 years old now. Wow. And I just got so excited. The more I looked at it, the more I realized that these two guys, back in the early days of computing, had laid out the equivalent of Newton's laws of motion for software development. They had laid out, here's why software development costs so much, and here's what you can do about it. But the examples were dated, to say the least. There was a long discussion of higher level languages versus assembly language. Who's going to win? There were examples with paper tapes and punch cards. And I thought, people just aren't going to get this book because the examples are out of date. But the principles are absolutely dead on. Oh, I was so excited. So I got to meet Ed and Larry, had a memorable breakfast with them. We were on the panel. They kicked my butt, as you should in a situation like that. They were my elders. And at that time, I vowed I'm going to write the updated version of structured design. And the heart of structured design, the heart of the argument, is that coupling is the key issue in software design. And they had a very specific definition of coupling, which we kind of lost, and I'm going to advocate for coming back to here today. Their definition of coupling is two elements in a design are coupled if, when you change one, you have to change the other. That's the original definition of coupling. And I'll get into why that's expensive and what we can do about it as I get through the talk. So, 2005, how hard can this be? So many worthwhile and annoying things start by asking, how hard can this be? And so it was with this book. I started collecting examples. I figured I knew how to design software. So, yeah, I just have to explain what I'm thinking about when I do a good job, and we're finished. So I came up with the one kind of branding, overarching view of what I meant by design, and that went a little ways, and then it fell apart, and then I did some other stuff, and back and forth and back and forth. So finally, 4 years ago now. 4 years ago now, I had some time, and I said, okay, I'm just going to start over from scratch. I have 2 weeks that are unexpectedly free. Let me just dive in and see how much of this book I can get written. Maybe I'm ready now. And I sat down, I started typing, and the first words off of my finger were, software design is an exercise in human relationships. No. Like, I'm all for that human stuff. I participate in it most days. But I want to talk about coupling and cohesion and power laws and making large changes in small, safe steps and all that. How in the world is this a story about human relationships? And the further I got into it, the more I wrote about it, the more I realized that every technical detail I was discussing really did come around to how people got along. And the reasons we had trouble with software design wasn't because we didn't know what to design. It's because we didn't get along. Trust is lost. Things are delayed unnecessarily. Incentives diverge and then collapse. That's what makes software design difficult. We need superior skills as designers in service of the relationships in software development. And I'll talk more about what I mean by that in a second. So then, book writing is a brutal exercise in scope cutting. I always start with an idea about I'm going to write a book, and I hadn't written a book for 15 years, so already I'm like, can I still do this? Turns out, if you just put your butt in the seat and you type long enough, you'll have a book. I don't know what it's going to be about. I don't know if it all hangs together. I don't know if anybody wants to read it, but 50,000 words is 50,000 words. So yeah, I could still write a book. But the process is always the same. Here's a topic, oh, that's way too small. I couldn't possibly write a whole book about that. Right. Oh crap, that's way more than it's gonna fit into one book. Which part of it, I want to talk about all of it. Oh, which part of it am I gonna talk about? Okay, this little part here, all right, but that's way too small to fit in a book. Type. Oh, crap, that's way too much to fit into one book. Which part of it? So I went through that at least 3 times, and I came up with the first book that I published last year called Tidy First, ? If you're thinking of writing a book, don't put punctuation in the title. Just like as a logistical matter, it's a pain. So anyway, I have this book with a punctuation in the title called Tidy First. And here's the moment. I wanted to talk about software design in modern society, but boiled it down to this moment. Every programmer encounters this moment 20 times a day. There's some code. I need to change it. It's a mess. Do I tidy first? That is a software design moment. It's the smallest quantum of software design that you can do. Because sometimes you can just power through, but sometimes you're like, well, let me make my job a little easier before I do my job. And should you tidy first? The answer is sometimes yes, sometimes no. Probably yes. But don't get carried away. Now you don't have to read the book. So, I knew I was going to do that. All right. Okay. So that's the micro. That's the book that came out last year, Tidy First. And I'll talk about some of the themes in it. But for today, I'm working on book 2, which is called Tidy Together, about how Tidy First is really about your relationship with yourself. You're a programmer. You have to change some janky code. This is self-care for programmers. Let me just extract some helpers before I change things. Oh, but I don't have enough time, and I should be able to power through this. Or maybe you're like, no, let me just make my job a little easier. Okay, so it's about your relationship with yourself. And there's technique involved, and there's theory behind why it works and when you shouldn't do it. Tidy Together, the book I'm working on now, is about teams of programmers working together. Now we have interpersonal relationships. As difficult as intrapersonal relationship is, interpersonal, oh my God. This people stuff is not my strong suit, let me tell you. But as designers, when we make design decisions, we're not just interacting, and we're in a team, we're not just interacting with the code anymore, we're interacting with our whole team. Maybe not this moment, but over time. So, how's that going to work? What I'm going to talk about today is even a step back from that. And kind of where I'm going with this, I'm imagining a trilogy where Tidy First this is about you and yourself. Tidy Together is about your immediate colleagues. And the third part of the trilogy is about the relationship between technology and business. And that'll be more at an architectural level if I ever get around to writing it, but we don't know these things. I have plans, but okay. So that's where we are. I like handwriting my slides because then if I have a thought, we can all share it. Here's what software development looks like at the highest levels. Somebody has an idea for how the software is going to change. Oh, I forgot to mention that. Why do we design? So we can change things. We have the software. It runs the way it runs. We don't care. The computer doesn't care how it's designed. If we don't have to change it, we don't care about how it's designed either. It's only when we want to change its behavior in some way that the design becomes important. So, somebody has an idea for how the system could behave differently. Now, maybe it's behaved differently with respect to users. Maybe it's behaved differently with respect to the resources that we use, with operations. But the behavior of the system, as observed from the outside, has to change in some way. And then we implement some feature. And part of the magic of software is the more features we implement, the more ideas we get, which is a good thing. And if this was all there was to software development, it really would be, I mean, it's difficult, but this is relatively straightforward. Fortunately, unfortunately, it's just true that there's another layer. Under the water, we don't just implement the features, we implement the features in the presence of some structure of the system. And the structure of the system profoundly affects how expensive those features will be to implement. And the structure's never right, is never perfect. Now take the tidy first example where I've got a dysfunction and it's kind of janky. The structure's wrong. I can change the structure so that the change I'm about to make is easier to do. That's the tidy first flow. So I have an idea. First thing I do is change the structure. Then I implement the feature. And here we're already starting to come into conflicts. Those features are very visible to everybody who's affected by the software. The structure is only visible to the programmer who's walking the path. Nobody else can see that. So the intuition that I hear over and over from programmers is we're not investing anywhere near enough in the structure of the system. Technical debt is the classic example. And part of the reason for that is that structure is only indirectly observable. The investors in the software and the users of the software might be able to see that features are coming more slowly than they used to be. They might be able to see that there are more defects than there used to be. And that's caused by an underinvestment in structure. But by then, it's way too late. So part of the goal of this, I call the whole theme of what I'm studying empirical software design. And I'll say what I mean by empirical in a second. The goal of empirical software design is to bring balance to the investment in features and in structure. Now, part of the magic of software is sometimes you implement a feature and that leads you to realize that the structure could be better. Oh, we want to implement a bunch of things like this. So let's improve the structure and then future features will be easier. And the economic magic of software is sometimes the structure suggests ideas. Oh, implementing these kinds of things is easy, so let's just do that. I worked at a payroll company called Gusto for 3 years. And we kind of accidentally implemented two payroll calculators. Now, payroll calculation is really expensive, complicated, difficult to implement in the US anyway. 8,700 tax authorities in the United States. Yeah. Seems like it would be easy. It is definitely not easy. And we had 2 copies of it. Just, whoops. Somebody implemented one over here for good reason. Somebody else implemented another one over here for good reason. Now they both got maintained. And, it was a small company. We felt the pain of it, the opportunity cost lost because we had to update in 2 places at once. But when's the activation energy ever going to be high enough to unify the 2? Well, eventually it did get high enough. Oh, did you know that about the frog? The frog jumps out of the water. Frogs don't actually boil to death. Eventually, there's some kind of random-y moment where they just go like, no, this is too hot, and they jump out before they die. Anyway. You never know where the value is going to come from in a talk like this. So there. So eventually, the activation energy was high enough. We took the time, and it took a long time, to unify the 2 payroll calculators. And then somebody said, oh, you know what? Since now it's easy to call the payroll calculator, let's embed the payroll calculator in our homepage as part of our marketing. Oh, okay. And it became a very popular feature. You could just go to gusto.com, type in the requirements for this month's payroll for 1 person, poof, out comes the answer that you really could, you could copy those numbers with a pen and put them onto some piece of paper, because this is America. Okay, I can't go down that road. Okay. But we would never have implemented this marketing feature if it hadn't been cheap, number 1. And number 2, we would have never implemented this marketing feature if somebody hadn't known that using a payroll calculator was cheap today, where it was really expensive 3 months ago. And that's another source of value in software. Part of this, I don't want to waste my time, is I don't want to waste opportunities. And software has this magical nonlinear payoff function where sometimes you can cross a threshold and either dramatically increase the value of a feature or dramatically reduce its cost. And that's what I'm going for here. I don't want things to be I don't want to work a little bit harder for a little bit more value. I want to work a little bit different for the chance for those jackpot payoffs. That's what I'm going for. And when I say jackpot payoffs, it might be money, it might be satisfaction, it might be societal impact. As a good geek I'm just going to ignore which of those goals I'm trying to achieve at the moment and just see if it's possible. Okay, so we want to do software design so we can change the software so that we can achieve these nonlinear outputs. What are the constraints on any process of design? I'm not going to tell you how to design, but I am going to be uncompromising about saying what the constraints are on any style of design that you choose. So the first constraint is, as I said, social. What are the social constraints for software design? We have to get along. We have to build and maintain trust. We have to repair relationships when they've been damaged. If I have an API and you're calling the API and I want to change the design of the API, and I go to you and I say, new API, sucker. That qualifies as high-class social skills for me. So, okay, you have to change all your code to call the new API. you're not going to be happy with me if that's how I approach it. So the way to address that is to align authority and responsibility. If I create work for other people, I go at least help do that work. Better yet, not to create work for other people. Now, the work might be, okay, there's some code, and it called the old API, and now it calls the new API. But there's also, you had to understand the thinking behind the old API, and now maybe you have to understand the thinking behind the new API. And it's my responsibility as the designer, the person making the design change, it is my responsibility to make sure that everybody learns what they need to learn in order to adapt to the new design change. It's not enough to just merge these two files. That's the beginning of the story. The responsibility of the designer extends throughout the social relationships. Another constraint that any style of software design has to deal with is incentives. If you're going to design software, you need to recognize that everybody's incentives are not the same. There are people who just love designing software and who don't particularly like designing features or implementing features, and vice versa. And neither of those people is an idiot, necessarily. There's different perspectives on it. There's oftentimes a product organization whose incentives are aligned with features, and an engineering organization whose immediate incentives are more aligned with the structure. And those two don't match up. It's okay. We don't all have to see things the same way, but we do have to agree on what next step to take. So any style of software design is going to have to acknowledge the fact that incentives diverge, and yet we have to come together in order to get our needs met. A third constraint on software design is that the social fabric is going to change over time. So juniors don't stay juniors forever, not if you do it right. Seniors don't stay seniors forever, not if you do it right. People come, people go, markets change, technology changes. The social structure that you build is going to change over time. Now, is this an advantage or a disadvantage? Okay, I'm old. I've seen stuff come around multiple times now. Like the whole AI's coming for your jobs. Yeah, Case was coming for my jobs. The compiler was coming for my job. Fine, sure. If you have questions about that, I'll answer the questions, but I'm not going to interrupt this, even though I have a great rant about AI and programming. So the social structure, we're talking about design as a socio-technical system, and it's the first derivative of that socio-technical system. The people involved are going to change, their relationships are going to change, and the thing they're working on is going to change too at the same time. Oh, and I even remembered why I claim to be old. Documentation. Documentation's back. I mean, the whole waterfall's back, but that's another rant. But documentation is back. If only you had written down everything you were thinking as you were programming, I wouldn't have to go figure it out. You know what? That doesn't work. By the time you need to read the documentation, it is out of date. And if you try and break that constraint by keeping it up to date, okay, that was not a very compassionate way to say that. It's just going to be more, it's a snowplow. More and more work until you abandon it entirely. So there's a lot you can do to communicate through code. I've written 2 books about it. And there's more than what's in the books. But documentation is not going to fix this problem of social change. So that's one set of constraints. Another set of constraints are the features of the medium that we work with as software designers. Somebody on the stage said they just hated Venn diagrams. Trigger warning. Here comes one. Okay, software is different than other mediums for engineering. What we do is genuinely engineering. But the medium we work with is different. And if we're going to be designers, we need to take those differences into account. So the nature of cost in software works like this. And I called this, in the tidy first, I call this Constantine's equivalence. Because this is the argument that Larry Constantine made in structured design. He said the cost of the software is mostly in the cost of changing the software, not writing it in the first place. But all those changes aren't really the same. There's different kinds of changes. There's lots of little changes, and there's a few really big changes that you have to make. So the cost of the changes is actually the cost of those big changes mostly. And the cost of those big changes happens because software is broken into a bunch of parts. Those big expensive changes come from, I change this part, which means I have to change these 4 parts, which mean I have to change these 75 parts, which mean I have to change these 4,000 things. That's the nature of the big changes. If we took a bag of features to add to our software, implemented them in any order, we would discover that most of the changes were easy, and every once in a while a change is going to be ridiculously hard. 1 week, 1 week, 1 week, 6 months. Why? And from the outside, if you don't know anything about the structure, this seems like programmers just want to go on vacation. Oh, you're just going to leave for 5 months and 3 weeks, and then you're just going to implement the feature in the next week. But that doesn't happen at random. The reason it happens, and this is part of the beauty of studying software design deeply, this is a natural process. This is exactly the same process that results in avalanches. Most avalanches, 1 snowflake falls over, that's it. Not much of an avalanche. But if the exponent is ever so slightly greater than 1 snowflake falls over and it moves 2 more snowflakes, and the 2 more snowflakes all over, and whoosh. This is the same exact kind of process involved in these gigantic jackpot changes in software development. I make a change here. Oh, I got to change those things. I got to change those. Oh, and that means, I really wish that I had, except I didn't, so now I have to go and. So if we want to address the cost of change, we design because we want to change. We want the changes not to be expensive. If we want to address the cost of change, we have to recognize the structure of these costs. Do I 20 minutes? I wrote this talk yesterday And one of the things about writing talks is the first time you give it, you have no idea how long it's going to take. So ask me a question about power law distributions if you want to ask a question about it. I'm going to leave some time at the end for questions. But I'm not going to talk about it now, even though it's a really cool topic. But what we're dealing with here is the cost of coupling. And as I said, coupling has come to mean, sometimes it's dynamic. Oh, I have this service and it calls that service, and so they're coupled. No. There's something. There's a relationship between those two services. If this one goes down, this one goes down. We can talk about that. But we're talking about the cost of making changes to the system. And the elements are coupled with respect to a particular change if changing one implies changing the other. If I change the name of this function, then I have to go to all the callers and change the name also. But if I change the formatting inside of this function, I don't have to go change any callers. So they aren't coupled with respect to formatting, but they are coupled with respect to naming. It gets more complicated than that, because what if I have an IDE that lets me change the name and all the callers all at the same time? Are they coupled anymore? Nope. One change. Doesn't spread, doesn't go anywhere. Coupling is about the propagation of change. Of course, then, if I have external customers for the function, it's part of an API and I want to change the name. Now I can't change it in just one go. And so there is coupling, and it's external coupling, and that's even more expensive. So we can dig into layers and layers of coupling. But software design needs to deal with coupling. Anytime you're dealing with coupling, you're in a trade-off space. You know, this is the international symbol for a trade-off space. So you're in a trade-off space. You have the cost of the coupling. Okay, if I change this, I have to change those 4 things, which who knows what's going to happen there. But you also have the cost of decoupling. If I find some way to eliminate that coupling connection between the two elements, but I have to pay to do that. So where am I in that trade-off space? Is it worth it to make this design change or not? Okay. We're good, I promise. And so that's we have two legs on the stool now. But there's another leg, which is the economic constraints on software design. And this is something that took me a long time to learn about. Helped to go implement a bunch of financial software, so I had to actually grapple with the details of the calculations for these concepts. You know, that's how, as programmers, that's how we learn. We program stuff and then realize we don't understand it. No better way of realizing you don't understand something than to program it. And the programmer, your computer's just so uncompromising about telling you about, you're an idiot. So, economics. 3 factors that are all extremely important. And the reason I bring economics into this is I see so much well-intentioned advice about software design that ignores economic realities. And you might be able to do that for a little while, but if somebody's paying you to design the software, you can't ignore it for long. So this is where all the big design up front isn't ineffective because it's stupid or hubristic or no. It's ineffective because it ignores the economic drivers if we want our activities to be sustainable. So the first one is just survival. I read the book Ergodicity by Luca Delano last year, and it really rewired my brain. Software starts in a default failure mode. You start to write a program, it's probably just going to go away. And then maybe it's becomes successful and it starts growing, but the default mode is still that you're going to fail to grow. And it's only when you cross that threshold of sustainability that the default becomes, okay, the software is going to last quite a while. And if you ignore those first two phases, what I call explore and expand, and the software just doesn't survive at all, now we're back to those 3 billion seconds. Well, why did I invest my time in doing this work if the whole thing was just going to fail? So whatever style of design we choose is going to have to improve the chances of the survival of the software through those early years. The second economic imperative is net present value. And this is a concept that took me a while to hammer into my thick skull. Time, and it boils down to the simple statement, time is money. But here's why it matters. When you spend €1 is as important as how many euros you spend. Put another way, earning sooner is exactly the same as earning more. So if we're going to design and we want to create more value, earning sooner creates value. Oftentimes you can't control how much you earn, but you can control when you earn it. And the same is true of spending. Spending later is exactly economically equivalent to spending less. So a software design style that pushes costs out into the future is creating value. Maybe even if you end up spending more later, the trade-off may be fine. So NPV is part of why designing up front is a bad idea. I'm going to invest all of these the money into these design decisions today for some future payoff. Well, if we take one of those design decisions and we can push that out into the future, that means we earn that much sooner, we pay that much later. We've created value by moving one of those design decisions out into the future. Now, me being an obsessive person, I just want to say, how many of those design decisions can we push out how far into the future? Let's see how far we can push this. But that's the second economic imperative. And the last economic imperative is optionality. That is, what can I do with this software in the future? So, as we said, software design is preparation for change. The more changes you can make in more different directions, the more valuable the work that you've done is, in whatever dimension we're measuring that success. So if I have one system that takes in €1 million a month and another system that takes in €1 million a month, but I could change it 8 different ways to do new things that might increase future earnings, I'm going to pay you more for the system with the options. In software design, investment in structure creates options. At Gusto, once we'd unified the 2 payroll calculators, we had new options for what we'd implemented in the future. Did we know at the time we did it, did we know that we'd created value? kind of engineer gut says yes. 2 payroll calculators? Are you kidding me? Just aesthetically displeasing. And now they're unified. Did we know how we were going to use it? No. But it was already more valuable. So one time I got a book on options pricing algorithms, and I just implemented them all because, anyway. And that's where I really learned, I had an intuition for optionality. And the beauty of options is that the less predictable your environment is, the more the options are worth. Usually you'd think, okay, I want some very predictable revenue stream. But if you have options, you want things to be wildly unpredictable so that you could do whatever it is that you want to go in whatever direction. So these factors are what steers any style of software design. And you can ignore some of these constraints for a little while, but the constraints aren't going to ignore you. If you practice a style of design that doesn't meet one of these constraints, that will catch up with you at some point. And I don't like those kind of surprises. I would rather take a step back, look at it, say, all right, well, this is a way harder problem than should we use event sourcing? Just to pick on a favorite design decision, which may or may not be a good idea, at some point in the development of the system. Okay, so that's the constraints. What are the implications of this that I draw? Now, you can draw whatever implications you'd like, but what are the implications that I draw from this? Well, and this is something that Dave Farley said, grow like a tree. Most of design is going to be differentiation. I make a thing, I split it into parts. I take one of those parts, I expand it, eventually it splits into more parts. That's what most of software design is going to be. So I start with something that's very small, it's just a seed, and then one little root and one little shoot with 2 little leaves on it. That's an oak tree. There's already an oak tree. This is a very, very small oak tree. So now their differentiation falls down when you have duplication. When you have duplication, like the 2 payroll calculators, then you also have a unification activity that takes place. But mostly, we're going to grow like a tree grows. Second implication I take here is that design is an activity. Now, I wouldn't think that I would have to explain that, but this is the extreme programming. You know, we had these big phases with meters of documentation that were the concrete manifestation of the phases. Extreme programming said, no, we're going to take all those activities. All those activities are valuable. You have to do them. But it's a question of when. We're going to take the phases and we're going to turn them into activities. So if design is an activity and it's going to be taking place periodically as we go along, that requires a different style. So, for example, this feature hamster wheel or the Jira pellets, where there's just always another feature and always another feature, and the pressure is always to implement the next feature as quickly as possible. That's leaving so much money on the table. That is picking up crumbs, and the cake is sitting right there. We want to bring balance to the investment in features and in structure. If design is an activity, then some of the design changes we make are going to take a while. And if they're going to take a while, I have to think, then we're going to have to interrupt the design change in order to get back to features. There's a quote in one of my early books. It says, I'm trying to heal the rift between business and technology. And I still feel that way. Part of the rift is that moment when you say, we have been on the hamster wheel for a long time. It's such a mess. We have to just stop and fix this. We have to stop for 6 months and fix this. That is such a relationship killer. Well, 6 months from now, I'm going to have software and it's going to do exactly what it does today. It's the best case. Ugh. So we need to, there's features going in, and there's design activities, and this feature, design. That ignores the realities of the human relationships we're talking about. Now, the design, feature also ignores the economic realities, and also your sponsors probably want to start seeing some features. So, there has to be this kind of interlacing of feature and design back and forth. Now, once you do this, does it matter if people say, oh, you just don't want to design at all? I want to do some design up front. Fine. That much. Do that much design up front if we're going to grow like a tree grows. But it's not months worth. It's just a bit, because you're going to get to design again in the future. I think that's the fear for programmers. It's like, well, they're just never going to let me refactor. So I'm just going to design now. What if they did, though? So the key technical skill in this interruptible style of design is working in parallels. Having the old design and the new design exist for a time together. And I see this at all scales. If I want to change the type of a parameter to a function, I'll add a new parameter with the new type. Make sure everything's okay. I can push that to production. I'm good already. It's interruptible. Then I replace the use of the variable or the parameter with the old type with the parameter with the new type. Again, I can still push to production even though I have an unused parameter. We're fine. Then I delete the old one. So that's a micro version of parallels. If you're willing to do the extra work to include parallels, then your design activities are always interruptible. And if your design activities are always interruptible, you'll be able to serve the relationships that are driving development more smoothly. There's another implication, which is at the macro level, changes to features and changes to structure are just happening all the time. It's just this mess. It's as a symphony. That sounds so much better. Or maybe a jazz combo is slightly closer. At the micro level, though, I practice an absolute split between feature changes and structure changes. So if sometimes you program along, you're like, oh, and the name of this variable is a little wrong, and let me put an if statement in here, and you've mixed feature changes and structure changes. I go back, start over so that they're absolutely split at the micro level. At the macro level, that enables you preserve this illusion that the design's getting better and we're getting more features all the time, which is the best you can have. Let me close with one more, and this is something I've just been exploring lately, and it's kind of it's a little in a different direction than the others of these. If you want to lead a software project and you want the kind of benefits that I'm talking about, relationships that strengthen over time, with features that improve over time, with structure that improves over time, you're never going to get that with pressure. Pressure, if you just, could you just stay a couple extra hours? Could you work a little harder? Is never going to achieve that, because software design is a creative activity, and creative activities need space. But they also need impetus. And leading with purpose instead of with pressure is what creates that combination of impetus for change and space for creativity that allows us to more fully realize our potential as programmers, this remarkable medium that we get to work in, and realize that potential for our own satisfaction of the users whose lives we affect with the decisions we make every day, investors, and eventually society as a whole. Thank you very much.